Okay, so before moving on to encoding some more instructions, I just want to have a look at the enter test that I did previously, because I did these tests where I've got this 16-bit immediate, but I didn't test a smaller number that would fit within an 8-bit immediate. And so in my system, if I create an immediate that fits within 8 bits, it gets marked as an immediate 8, which means that it actually won't find a form if I do this, because the form that I've written specifically asks for an immediate 16. So if we go and just regenerate the listing and run the tests, you can see here that now it can't match a form for enter. So if I go to the forms and look for op enter, in here, instead of immediate 16, I actually want something like immediate fits 16, which I don't have, but I do have immediate fits 32, so I can just copy the implementation of that and change it to 16. So now it's getting a match, but it's not outputting the immediate because it doesn't know how big it's supposed to be. So it's getting the second immediate here, but it's not getting the immediate for the first operand here. So if we just go to the bottom of emit, basically this one, and actually I may as well do it for 32 as well, it needs to check if it's any of immediate 16 or 32 or immediate fits 16 or 32. So in these cases now, it should generate correctly and the tests will pass. The other thing that I want to look at is the op type that I've got. So this was originally like operation, but it's basically just being used exclusively as a mnemonic. So I'm just going to rename it to mnemonic. And it's getting a bit much to have to always prefix the mnemonics when writing encoder code, or doing the function calls and stuff with this op prefix. The original reason for having this op prefix was because I was worried that the names would conflict with things, but since everything is now uppercased, I don't really see any way that it could meaningfully conflict with anything, so we'll just get rid of them. So I'll have to update encoder test as well. There's case in here which uses mnemonic. And there's a test case.op that needs to change, and then forms also uses it as well. So we'll just go and remove the prefix from all of these. Okay, let's run the tests again. Undefined op in encoder. That's because we accept it as an argument. Okay, so that's all done. So moving on to instructions, I'll add a couple of arithmetic ones, specifically for carry arithmetic. So if we go to the documentation, we've got, for example, ADC here, which is add with carry, and then there's also SBB, which is sub with borrow. So I'll add these ones first if I go to the encoder ASM. These ones are actually the same as add and sub, so I can just copy the add and sub tests. And we'll just rename these ones to ADC, and then these sub ones can rename to SBB. So let's just go and add the mnemonics. We've got ADC and SBB. And we'll find the forms for these as well. The forms are actually basically the same with just a few changes. They still have all the same special cases for the AX register and you know, like short forms for 8-bit immediates. So I'll just change this to ADC and this one to SBB. Let's regenerate the listing, do a test. Okay, oh, I need to add the add to encoder test. So we've got add. Let's just go and copy these ones like I did in the assembly file. So we'll just copy all of these. And then these ones can rename to ADC. And these ones can rename to SBB. Okay, so now they generate the incorrect bytes, which should be expected. So I just need to make a few small changes to the form. So with ADC, instead of 0, 4, or 0, 5, this is now 1, 4, and 1, 5. This is now opcode extension 2. And then these just have a 1 in front of them as well. So that's all of the ADC ones working. So let's just go to SBB. SBB has, instead of 2, this should now be 1. Instead of opcode extension 5, this is now 3. And then instead of a 2 in front, this is also a 1 now as well. Okay, so that's the carry, add, and the borrow sub. Next, I'll put in increment and decrement. So let's just go and find those. We'll start with increment. So inc is here, and this one. So there are a few different forms here. These two at the bottom here, though, are not encodable on 64-bit mode. And that's because this opcode here is actually for something. You know, this is the encoding where you put the operand into the opcode, you OR it with the opcode. But because this opcode is for something, this is actually the same as the rex prefix in 64-bit mode. So these are not encodable in 64-bit. So I can ignore these ones and just focus on these ones instead. So we'll do some tests first, or we'll add them here first. We'll say inc and dec. We'll add some empty forms to the table. And then we'll go and add some tests. So we have, this is RM encoding, or this is M encoding, so you get the register but also memory operand choice. So we'll do, let's say, CL, CX, ECX, and RCX. And then we'll just take these. This one will be byte, word, dword, and qword, because these ones will all change to RCX for memory access. And then decrement is basically the same usage, so we'll just do decrement immediately after it. So let's just regenerate that listing. Go to the encoder test. I can probably actually just copy these ADC ones and do inc. So instead of AX here, I'm using CX, and then instead of an immediate, this should now be NA. Then we'll copy them again and change these CX to a memory access, and then copy them again and change this to decrement. Okay, so we couldn't match forms, so we'll just go and fill in the forms. So the forms for this is that we've got one opcode for the byte and then another opcode for the other sizes. So here we'll have width, which will be bytes. Op_n for this is M. Op_1 can be a register or memory. And then it's just opcode is 0xFE, and then it has an opcode extension of 0. Then the other sizes, word, dword, and qword, have the opcode FF. Now we can take these for decrement because they're basically the same. I think it's just the opcode extension that changes in this one. Yeah, so this is opcode extension 1. Okay, so that's increment and decrement. Next, I will do a couple of shift instructions. So basically there's shift left, shift right, but there's also double precision shift left and shift right, which are basically this SHLD and SHRD. So we'll do a test for each of these. This is actually the same pretty much as shift left. So shift left here has a lot of different cases, but what they've got like a special case for like a hard-coded immediate of 1, but they've also got this immediate 8 and CL with RM. So this shift left double precision is just the immediate 8 and CL version. There's no hard-coded 1 version, but the rest of it is basically the same, and they just have an extra operand. So if we go to the tests for this and look for shift left, let's say, we'll just take the shift left tests. Actually, we can take all of these tests, and we'll just put them underneath here. So instead of just shift left, this is SHLD now. And then each of these needs another register. So maybe we'll do, let's say ECX or something. We'll use the CX one. We don't need these hard-coded immediates of 1 because these are just like special case tests. And then I just need to change the size of these registers. So this should be CL, CL, CX, CX, ECX, ECX, and then these two are RCX. Let's just take these ones down here and copy them in. Let's just make sure NASM is okay with that. Invalid combination, SHLD. Oh, there's no byte version. Let's just get rid of the byte versions. Okay, that's all right. And then we need a SHRD as well, which is going to be the same thing, but with an R. Okay, so let's just go to the encoder test. We'll have a look for shift left, and then before the rotate ones here, we'll just do the same thing where we'll just take, well, this time we'll take the SHR ones. We'll get rid of these number 1 immediate things here. We don't need the byte tests at all. And then we just need to change the mnemonic. So instead of SHR, this one will be LD. We've still got the DX register being used here, or the memory access being used. We want to change the second operand to just CX, and then the third operand can be as it was. So now let's put SHR in here as well. And now let's just go and add the mnemonic. So we've got SHLD and RD. And we'll add some empty form tables. Okay, let's do the test for this. Okay, so couldn't match the form, that's fine. This is basically, I assume, going to be pretty much the same as shift left and shift right here, but no byte versions and no 1 immediate version, so we can just copy these two. So one difference here is that these have the secondary opcode map. The opcode for CL is A5, and then the other one is A4, and there's no opcode extension either. Now, instead of op2 being CX or immediate 8, op2 should now be a register, and this should now be op3. And then the operand encoding for this is we've got MRC and MRI. So these are some new operand encodings that I don't have yet. We'll do the same for shift right double precision. But this one's going to use AD for CL and AC for the other one. So this one needs to change to AD. And this one becomes AC. So I'm going to just need to add the new operand encodings. So let's just take this one down here. We've got MRI. And we've got MRC. Let's just go and add these. So these ones need to set RM and reg. So I think we can just add them to here. Yeah, that all works okay. So a couple of bytes related ones now. We'll start with BSWAP. So let's just go and find BSWAP. So this one only has two versions here. There's just a register 32 and register 64. And these ones are the operand encoding that puts the operand into the opcode itself. So let's go to the assembly. I guess we'll just put these ones near the top. We'll just do BSWAP ECX and BSWAP RCX. Let's go to the encoder tests. Let's go to the top of these tests. And we just need BSWAP. So we've got DWord here. So this one was CX. And this one is just keyword. Let's just go and add BSWAP here. Let's just run the test quickly. Okay, that's fine. So when matching with DWord or keyword, op-n should be O. And then the opcode here is C8, and we have the secondary opcode map. Could not match instruction form for BSWAP ECX. So BSWAP with DWord. Oh, I need to add the operand. So op1 must be just a register. Okay, that's fine. Next is MOVBE. So this is basically move data after swapping bytes. So this one has word, double word, keyword, and then it's either register then memory or memory then register. So you don't get to, it's basically RM and MR, but they have different opcodes, which is why they're separated out like this. Let's just add MOVBE. Maybe we'll just add this to, I don't know, here or something like that. MOVBE. Just go and add the mnemonic. And then the encoder assembly test, we'll just do, I don't know, we'll just put it here. We'll just say MOVBE. So basically we've got register on one side. So this is, it's word, double word, or keyword. So we'll do CX with DX. Then we've got E and then R. Oh, actually, this side should be memory, really. So we'll do RCX here. And then we've got the same thing, but we'll just swap the operands around. Okay. So let's just go and find the tests for these. We'll just copy these ones. So this is MOVBE. And then here we've got, I did CX and DX, I think. But this one is actually CX with memory access. Oh, I'm just using CX for all of them, maybe just to change it a bit. We use DX for the memory in this one. So this is DX. And then just to test where we swap the operands. Okay, let's run the tests. No form, that's fine. So here we have, we need something that's going to match on all of the widths. So we've got word, dword, and qword. Op-n, we'll do rm first. So this is op1 is reg, and op2 is memory. Then we have map OF38. Map is 0F38, and then the opcode for this one is F0. Then for the other one where we swap around, so we're doing MR this time, so we'll just swap register and memory here. This is F1, but everything else looks like it stays the same. Okay, so there's a slight problem here. What is going on? So RM, we've got F0 for RM, which looks like it's correct here. Oh, it's because my assembly tests and my encoder tests are probably out of sync. Yeah, I need to regenerate the listing. Okay, that's fine. Okay, so that was a couple of byte ones, and then finally I thought I'll get another instruction in here which seems a bit unrelated, but I'll put it in anyway. This is CRC32. So this one is a little bit different in that we've got 3 forms here which are 32-bit destinations, and 2 forms here which are 64-bit destinations. And because of the source value, because of the source value, word, dword, and qword are actually unambiguous. These are unique within these tables. But these two here, these byte ones, are sort of a bit more unambiguous. Oh, sorry, a bit more ambiguous as to which one you should choose. So for example, if I said that the width was byte, which one of these do I choose? And because this is defined as, for example, down here it says, if the destination is an R64 register, then the 32-bit result is stored in the least significant double word, and then the top 32 bits are basically zeroed out. So this one, this one here will actually do the same thing as this one here, but this one is a shorter encoding because we don't need the rexw for it. So ideally what will happen is that if we say byte with just a register, then we'll choose the shorter encoding, but it would be nice to also support this one as well. And in this case, basically we'll just we'll match on the destination being marked as RM64. So if it's marked as RM64, then it will win and it will put the rex byte on, even though it's a longer encoding for the same behavior. Because this one is the same behavior, because if you're writing to a 32-bit destination in 64-bit mode, then the upper 32 bits of that register are zeroed anyway. So this actually has the same behavior as this one. So I'll support all of the forms, but the R64 form with the byte source will be like a special case that you have to explicitly opt into. And I think that NASM is always going to output the shorter form, so I'll have to just write the longer form myself, basically. So let's just go to the assembly tests. We'll put this above here, I suppose. We've got CRC32. So basically we have a few encodings for 32-bit registers, but with different sized like sources. So here we'll use DL, for example, for the byte one. Then we use DX and then EDX. Then we'll use... wait, these ones are wrong. We'll use RCX with DL and RDX. So that covers the register versions of these. And then we'll need to do... Let's use the RDX again. So this one is byte memory. This one is word. This one is dword. And then this one here is bytes, and this one is qword. So let's just check that that's all correct. That all seems okay. But if I go to the listing and look at CRC32, down here, if we look at these byte versions, so this byte version and this byte version, this byte version and this byte version, these two have the same output from NASM. That is choosing the shorter output. And the same goes for these two byte ones here. It's choosing the same encoding for them, even though they use different register sizes. So for this one, I'll actually do this. I'll just output the bytes as raw things, and I think maybe in NASM you have to do comma separated like this. Can't quite remember. But with this one, I basically want to test it as having the rex prefix. So I think with the rex prefix, we'll just say that it's on the beginning, like this. Let's just look at the encoder actually and see where rex is output. So rex is actually output after the prefix. So if we've got a prefix of F2, I should be putting rex over here. So let's just see. I think I've got the syntax correct there. Yes, so this is now the syntax for this. Bytes. Yeah, that's correct. That's correct. Then I just need to change this one as well. So this one, I'll do the same thing, where I'll just take this listing output, but I'll make this one a comment and just output the bytes directly. So we've got OX, then we've got the rex prefix, so this will be for 8. And then we've got the rest of these bytes here. That is incorrect. That needs to be separated there, there, and there. So let's just regenerate that listing. Go and check the listing. Okay, so these are no longer, we don't have any duplicate encoding outputs now. So let's just go and create these tests. So we got MOVBE is where I've put them. So above here. So we got CRC32. And then we're going to do the width is basically going to be the source width. So we'll do byte, word, dword. Then this one is byte again. Then this one is qword. And then we've got the same thing down here, but these ones are memory accesses. So we'll just add to all of these. We've got CX and DX, NA, NA. But these ones here, these DXs here, are memory access. So we just need to go and add the mnemonic, which I'll just add, I don't know. Let's add it down here with CPU ID and stuff. Okay, so let's run the tests. This should fail finding a form. And now I can just add the forms. So we'll do the generic forms first. So basically we want to match on the source, and if it's a byte one, it has a different opcode. So we'll say that the width is byte, op n is op n rm. Yeah, rm. Op1 can be a register. Op2 can be register or memory. Then we've got the prefix. So this is prefix F2. And actually we have a map as well. So we've got map is 0F38. The opcode for this one is OXF0. And then we've got another one for word, D word, and Q word, which is F1. Okay, so now we just have the special cases here, which are obviously not passing. So for the special cases, I basically want to say that if op1 is specifically marked as being RM64, then I will output it with rex is force W. So this won't work right now because I don't have RM64, but I do have RM32 and stuff, so I'll just add this to the W helper. I think actually I'm probably not going to bother clearing this stuff. So let's just go to this and change this to keyword. If it's keyword, we do 64. So this should still fail because it will still match the incorrect thing. But if I go to the encoder test now, for these two that have DB here, we'll basically say that the destination must be explicitly marked as keyword. And now it all passes because we've explicitly marked it as RM64, so it matches the one that will force the rexW output.